Hi everyone, it's Miss Costa here, and in this video we're going to go through the June 2018 paper 3 for the Edexcel Foundation tier. So for the first question, we've got a fraction to a decimal. We're told to write 9/10 as a decimal. This is a calculator paper, so if we're not 100% confident on how to use the decimal point, so essentially every number that is after the decimal point in this column is in the 10ths column. The second column is the 100ths column. So converting 9/10 to a decimal, we know that's 0.9, which means there are 9 in the 10ths column. So we would write 9/10. So 9/10 would be 0.9 because we know the 9 would be in the 10ths column. But if we don't like that method, another thing we can do to turn a fraction to a decimal using a calculator. This little line here means divide, so we just write 9 divided by 10 into our calculator, and that would give me 0.9. Next, I need to write 0.3 as a percentage. So to turn a decimal into a percentage, all I do is I multiply by 100. So 0.3 times by 100 is 30, so I'd write 30%. In this question, I'm rounding 2,538 correct to the nearest 100. So what that means is I want to look at which digit is in the hundreds column, which is the 5. I'm going to circle it. Look at the digit next door, which is the tens column. And I want to decide whether I'm going to round up or round down. If the digit next to your circle number is 5 or more, then you round your number up. If it's 4 or less, you round it down. So what rounding down actually means is if I think of my number 2,538, it's just a floating number, and I know that it's going to be in between the hundreds around 500, would be 500 and 600. So essentially I'm trying to decide whether the number is closer to 2,500 or 2,600. Now halfway between 2,500 and 2,600 would be 2,550, and that's why if the number next to the 5 is 5 or more, it would be rounding up to 2,600. If it's less, it would be rounding down. Okay, next I've got a sequence. So I'm told that here are the first 4 terms of the sequence, and I need to write down the next term. So whenever I've got sequences, I can just look to see what's happening. So how am I getting from one term to the next? So what do I do to get from 2 to 9? I'm adding 7. From 9 to 16, I'm also adding 7. From 16 to 23, I'm also adding 7. So generally sequences are always going to be going up by the same value. So in this case, the sequence is going up in the 7 times tables. So to write down the next term in the sequence, I would also add 7, and 23 add 7 is 30. So it asks me to explain how I got my answer. I added 7. And then I need to work out the 10th term of the sequence. So this is where I need to actually use what is called the nth term, which is the rule of the sequence. And you work out the rule by first of all deciding what times tables your number goes up in. So it's going up in 7 times tables. So we're going to write 7n. But if it was the 7 times tables, this is what it would look like: 7, 14, 21, 28. So I want to say it's the 7 times tables, but actually each time, instead of being the actual 7 times tables, it's 5 less, because 7 take 5 is 2, 14 take 5 is 9, 21 take 5 is 16. So therefore it's the 7 times tables take away 5. So the nth term is 7n take 5. That is the rule of the sequence, and we can use the rule of the sequence to work out a given term. So in this case, it's telling us to work out the 10th term of the sequence. So n represents like the position in the sequence. So if it's the first, second, third, fourth. So in this case, n is 10, because I'm trying to find the 10th term. So 7n, what does that mean? It means 7 times by n. And then I'm going to take 5. So I know that n is 10. I'm going to substitute that into the rule. So I'm going to say 7 times 10 take 5. 7 times 10 is 70, and 70 take 5 is 65. If this is too confusing, another way that you could do it is just by keep on adding 7. It's a calculator paper, so that shouldn't be too hard, but generally it's really good to know how to work out the nth term. Okay, next we've got a place value question. So I'm told to use 3 of these digits to write down the largest possible 3-digit number. So when we've got numbers, then the digit on the left, so the first digit, that holds the greatest place value. If it's a 3-digit number, this is going to be the hundreds column, this is going to be the tens, and this is going to be the ones. So I want the largest possible digit to be in the hundreds column, and the largest digit is 9. I then want the next largest digit to be in my tens, because that's the next largest place value. So that would be 7, and then 4 would go in the ones. So 974. For the next part of the question, I'm told that there are 4 different digits, and I need to put one of these digits in each box to give the smallest possible answer to the sum, and I must use each digit only once. So I'm going to be adding, and I want my final answer to be the smallest possible value. So this is the tens column, this is the ones. So in both of these cases, the tens is going to be the thing that has the most value. So again, I want to use my largest numbers in the tens column. So I'll put 8 and 6 there. And then it doesn't really matter which one I put. I could put 81 and 62. Both options are going to give you the same answer. So, oh, sorry, I misread it. We're trying to get the smallest possible answer. So I'm going to actually do the reverse. So I want the smallest possible answer. That would have given you the largest, the smallest possible answer to the sum. So I'll put 1 here and 2 there, and then just do the reverse. So I'd get 16 and 28, where you could have got 18 and 26. Important to read the question. Okay, next we need to write down all of the factors of 30. So factors are numbers that multiply into your number. They're always going to be your number or less. So the factors of 30, a great way to do this is by doing factor pairs, which means you start with 1 and you try all the numbers and you figure out if it multiplies into 30. So 1 times by 30 is going to give me 30. I'm then going to try 2 times by 15. And this is a calculator paper, so you can literally just type them into your calculator, do 30 divided by 2 and so forth. Then I try 3, which is the next number, 3 times 10. 4, I'll try. That doesn't divide exactly into 30, and factors of a number need to be whole numbers. So therefore it cannot be 4. Then I try 5, and 5 times 6 gives me 30. The next thing I could try is 6, but I already have 6 on this side here. So once I've done that, I know I've found all of my factors. And if you work up from 1, then there's no chance of missing them. A lot of time people just miss 1 factor and then they can't get the 2 marks. So they always come in factor pairs, and doing it this way just makes sure you get all of them. So I'm going to work my way down the list and just write them all down in ascending order. So the factors of 30 are 1, 2, 3, 5, and then I work my way up here, 6, 10, 15, 30. Okay, next I have a worded question that is going to require some interpretation. So David has twice as many cousins as Becky, and Becky has twice as many cousins as Nishat. So Nishat has 6 cousins. What do I know about everyone else? So with questions like this, it's good to just write down what you actually know. So Nishat has 6 cousins. I need to work out how many cousins David has. In order to do that, I probably need to work out how many cousins Becky has. So Becky, what do I know about her? It says that Becky has twice as many cousins as Nishat. So if Nishat has 6 cousins, Becky's going to have 6 times 2, which is 12 cousins. Then I've got David. So David has twice as many cousins as Becky. So if Becky has 12 cousins, David's going to have twice this. So 12 times 2 is 24. So with questions like this, the actual question is quite simple. It's just interpreting it, which is why it helps just writing each piece of information that you know out. Then I've got using a calculator question. So you've got your calculator. The square root button is what you press first, and it's the one that looks like that. So you press that, you enter 1.44 times by 3.61, and then you get this, most likely if you have the new calculators. So once you've got your fraction, you press the format button, you go down to select decimal, and then it turns it into a decimal for you. So that would be 2.28. For the next question, we need to find the value of this. So it's a little bit trickier to enter this, but we can do the same thing. So we know it's going to be a square number. So we have to press this because the whole thing is going to be squared. I then open my brackets and I press 3.54, take away 0.96, close the brackets and do the little 2 for the squared number. So it should look like this. And then you use the arrows to move away from the square number. You press take away 4.096, and this time it gives you 2.5604. So when they're asking you questions like this, you're using a calculator, you're just typing numbers into a calculator. So they expect you to write all of the digits that you see. Okay, so this question we've been given a timetable, and we're told that it's part of a bus timetable between Bury and Manchester. So that means the way you read a timetable is your first destination is the one that appears first, and then the bus travels down, or I mean up the country, but chronologically time goes, the way it goes is down. So it starts at Bury, it takes 2 minutes, or no, 11 minutes to get to Whitefield. It then goes to Heaton Park, then to Cheetham, then to Manchester. So we're always going to be reading them down, and the time is going to be increasing. So it's telling me that the buses leave at 8:25, 8:55, 9:15, 9:30, 9:45 and 10:05 from Bury. And then the other times are just when they arrive at each other place. So the question is saying how many minutes should the 8:25 bus, so this one, take to go from Bury to Manchester? So it leaves at 8:25 and it arrives at 9:05. Now time is quite a tricky thing to do because there are 60 minutes in an hour. So people sometimes get confused by trying to do it with hundreds. The best thing to do is just find your way to each half or full hour. So I know that to get from 8:25 to 8:30, that would take 5 minutes. And then, so how can we show you this? So 8:25, let's do it like this. 8:25 plus 5 minutes takes me to 8:30. And then I've got a nice round number. So I know that I could get to 9 o'clock by adding half an hour, which is 30 minutes. And then to get to 9:05, that's another 5 minutes. So in total, I've got 5 plus 30 plus 5, which is 40 minutes. Obviously, for some people, time is a lot easier than others. So some people might be able to do this in your head. If not, break it up and just take it to the next easy part. So I'd say half an hour is a really nice things. Or you could do it every 15 minutes, whatever works best for you. Now, I'm told that Daniel goes from Whitefield to Manchester by bus. He takes 17 minutes. So he goes from his house to the bus stop. So again, just writing down all the information, extracting it from the question to make life simple for myself. So he takes 17 minutes to get from his house to the bus stop in Whitefield. It then takes him 15 minutes to get from the bus stop in Manchester to work. So he's going to end up in the bus stop in Manchester, and then he walks to work. So he has to get to work by 10 a.m. is the ideal time. He leaves his house at 8:45 a.m. So he leaves his house at 8:45 a.m. and I need to figure out if he gets to work by 10 a.m. Now, he goes from Whitefield to Manchester by bus. We'll look at the timetable in a bit. But first of all, it takes 17 minutes to get from his house to the bus stop. So 8:45 plus 17 minutes takes him to the bus stop in Whitefield. So 8:45 plus 17, again, try and break your number down to make life easier for yourself. So break it into 15 minutes. So 8:45 plus 15 is going to take you to 9 o'clock. And then 15 plus 2 gives you 17. So that's going to be 9:02. So he'll arrive at the bus stop in Whitefield at 9:02. Now what we need to do, so he leaves his house at 8:45, arrives at the bus stop at 9:02. What we need to do is look at the buses that are leaving Whitefield, which leave at 8:34, 9:04, 9:24, 9:39, 9:54, 10:14. So if he is there at 9:02, that means he'll be able to catch the earliest bus would be 9:04. So the 9:04 bus takes him to Manchester by 9:35. So he would arrive at the bus stop in Manchester at 9:35. It then says he takes 15 minutes to get from the bus stop in Manchester to work. So I'm going to add 15 minutes. So once again, I've got 09:35. Either you could add 15, because especially with your calculator, you've got 35 plus 15, or we could just break it down into nice easy chunks, add 10, so that would be 9:45, and then add 5, so that would be 09:50. Remember that time is out of 60 minutes, so when you get to 60, that's a full hour. So that means that he arrives at 9:50 at work. So does Daniel get to work by 10 a.m? Yes, he arrives 10 minutes early. So in questions like these, it says you must show all you're working. You'll get no marks if you just say yes. You need to show you're working, and you need to show each step of the way. Okay, next I've got a rate of pay question. Now, what this means is essentially how much you're getting paid per hour. So rate of pay is your pay per hour. So Bronwyn works in a restaurant, and the table gives her rates of pay. So on Monday to Friday, she earns £8.40 per hour. And on the weekend, she earns £11.20 per hour. So this is very common, especially for things like restaurants or retail shops. You get paid more on the weekend because people want to have fun at the weekend. Most people work Monday to Friday. And so therefore, if you work at the weekend, you get paid more. So it's very important that we are very careful with interpreting this question. I'm told that Bronwyn worked for a total of 20 hours last week. So in total, she's worked 20 hours, and she worked 8 of these 20 hours at the weekend. Show that Bronwyn was paid less than £200 last week. So once again, it's a show that question. So I need to show each step of my working. So the first thing I do is I know she worked 8 hours on the weekend. So if she worked 8 hours on the weekend and she worked 20 hours in total, that must mean I do 20 take away 8, which is 12. So that must mean she worked 12 hours Monday to Friday. So I've now got her 20 hours made up. If she worked a total of 20 hours, that must mean that the rest of the hours must have been worked Monday to Friday. So 8 hours on the weekend, means that for each hour she worked on the weekend, she was paid £11.20. So I do £11.20 times by 8. And for the 12 hours Monday to Friday, I'm going to do £8.40 times by 12. So that's going to give me £11.20 times by 8 is £89.60. And then £8.40 times by 12 is £100.80. So the total, remember total means you add everything together, the sum of everything. So add that together, £100.80 plus £89.60 is going to give me £190.40. So to show that, you say she was paid £190.40, which is less than 200. Okay, next I have got a question about percentages. So I'm told that last year the cost of a season ticket for a football club was £560. And this year the cost of a season ticket for the club has increased to £600. I need to write down the increase in the cost of a season ticket as a fraction of last year's cost. So let's have a look at what's happened. First, I need to work out what the increase is. So if it was £560 and it's now £600, the difference between the two, 600 take away 560 is 40. So there's a £40 difference. So the increase is £40. And I need to write down that difference as a fraction of last year's cost. So actually, I originally thought this was going to be a percentage increase question because I read it very quickly, but it's not. It's just asked you to write down the increase in the cost, which is £40. It's increased by £40. And I need to write it as a fraction of last year's cost. So £40 is the increase and last year's cost is 560. It's not asking me to simplify, so just writing 40 over 560 is absolutely fine. If you've simplified it, that's also absolutely fine. Okay, so now I've got a scale drawing. I'm told that the diagram shows a scale drawing of a tennis court and the scale of the drawing is 1 to 2000. So that's going to be 1 centimetre on the drawing is 200 centimetres in real life. So work out the perimeter of the real tennis court and give your answers in metres. So the measurements, we'd use our ruler and we'd measure the length. So the length, you want to be as careful as possible, should be 11.5. You are allowed a millimetre on either side. Sometimes they're nice and they allow 2 millimetres on either side. So if you've got 11.4, 11.6, 11.7, that's fine. But really try to line up your ruler starting from 0 and be careful with your millimetres. So my width is 11.5 and then the length is 5.8. So I need to work out the perimeter of the real tennis court. So first of all, what I'm going to do, I know that 1 centimetre is 200 centimetres in real life. So to work out the real life, I need to times my scale drawing by 200. To get from 1 to 200, I times by 200. So I'm going to do 11.5 times 200 and 5.8 times by 200. So what does that give me? 5.8 times by 200 is 1,160, and it's still centimetres. And the question's asking me in metres, so I want to be mindful of that. And then I do 11.5 times by 200, which is 2,300 centimetres. So I can then convert it into metres to just make my life easier. So I know that 1 metre is 100 centimetres. So to go from metres to centimetres, I times by 100. And to go from centimetres to metres, I divide by 100. So I'm going from centimetres to metres. So each of these I'm going to divide by 100. So that is going to be 1,160 divided by 100 is 11.6 metres. And this is going to be 23 metres. So 2,300 divided by 100. And the quick way to divide by 100, if your number ends in zeros, is to drop off the 2 zeros, but you've got a calculator anyway, so use it. So what does perimeter mean? Perimeter means the distance around the outside of the shape. So I know that this length here is 11.6, this one here is 23, and because it's a rectangle, opposite sides of a rectangle are equal. So this side is also going to be 11.6 and this side is also going to be 23. And perimeter is the distance around the outside of the shape. So it's helpful to kind of, you might have heard the phrase walking the perimeter, which is where prison guards literally walk around the perimeter of the prison, i.e. they cover the whole outside to make sure that nobody's escaping. So start from somewhere like here and think I need to walk along here. So that's 23, of the shape. And then I'm going to need to walk down here. So I need to add 11.6. Then I'm going to walk here. So add 23 again and walk here. So add 11.6. So 23 plus 23 plus 11.6 plus 11.6 gives you 301.4 meters. And this is why it's important to sense check things, because obviously that doesn't sound right. So I had typed in multiplication into my calculator by accident because I was rushing. So let's try it again. And that gives you 69.2, which sounds a lot better. So especially on a calculator paper, it's good. I mean, it's helpful if you just do a rough estimate. So we could just roughly estimate it. 11 is nicely rounded to 10. That's nicely rounded to 20. 10 plus 20 is 30. So I know the answer should be roughly 60. So getting an answer of 300 should be a big warning sign. Always double check your work. Okay, next I've got equation of a line. So there are some lines that we just need to know. And that would be the line y equals x. So it's a very simple straight line that goes through 0, 0. And essentially what it means is that whatever the x coordinate is, the y coordinate is the same. That is why y equals x. So your y-axis is here, x is here. So you'd have 1, 1, 2, 2, 3, 3, and so on. So y equals x is a really nice one to recognise because it goes straight through the origin, and whatever the x coordinate is, the y coordinate is exactly the same. So I'm essentially looking for a graph that looks like this. And the one that looks like that is this one over here. So let's double check. When x is 2, y is 2. When x is negative 2, y is also negative 2. So this is going to be the graph y equals x. The next type of graphs that I need to know are graphs of y equals or x equals. So this is your y-axis. This is your x-axis. And if you have, in this case, we're looking for y equals 2. If you had a straight line going down here, the coordinates, the x coordinates of that line, because over here x is 2, every coordinate on this line, the x coordinate is 2. That's 2, 0, that's 2, 1, 2, 2, 2, 3, and so forth. So vertical lines are the lines that are x equals. Now horizontal lines, like this one here, if I look at the coordinates here, every y coordinate on this line would be 3, because it goes through the y-axis at 3. And so therefore, if I literally listed any coordinate, like let's say this one here, that's -1, 3. The y coordinate is 3. So y equals lines are horizontal, x equals lines are vertical, and they literally cross the axes at whatever they say they do. So this one here is y equals 2. So I know it's going to be a horizontal line that crosses the y-axis at 2. So, well, the only horizontal line I have is this one here, and it crosses the y-axis at exactly 2. So that's going to be graph D. The next one is a little bit trickier, but again, we can apply the same logic. So I'm told that x plus y equals 2. Either I could rearrange it so that I get y equals minus x plus 2. And I know that the y-intercept, because every line is in the equation y equals mx plus c, I know that the y-intercept is 2, and I know it has a negative gradient, so therefore it's graph A. But we can still do that question even if we don't understand y equals mx plus c. So what you want to do is you just think to yourself, the x coordinate plus the y coordinate must equal 2. So let's just try these. 2. Over here, what's that coordinate? The x coordinate is 0, the y coordinate is 2. 0 plus 2 makes 2. Over here, what's this coordinate? The x coordinate is 2. And the y coordinate is 0. 2 plus 0 is 2. So therefore I know it's graph A. The other way is more complicated. Essentially, using the hill of gradients, you know, if the line is sloping downwards, it's going to be a negative gradient. So automatically, because it's a negative gradient, you can cross out this, and this is a straight line, so it's not going to be that. And then you just have to decide between these two. Now, you know that the y-intercept is plus 2, so it must be this graph over here. But yes, equation of a line is quite a big topic, so don't worry too much about that until we come to a question like that. Okay, stem and leaf diagrams. So you have been given the marks of 20 students, and you need to show this in a stem and leaf diagram. Now, the way a stem and leaf diagram works is here you've got your stem, and here you have your leaf. So the stem is generally like the key part of your thing. You're trying to order your data into something that makes sense. So the first thing we might want to do is just identify what your lowest number is and your highest number, and then the stem and leaf thing will make more sense. So the lowest number is, I don't know, maybe 64. Just looking at this, there might be a lower number. So lowest number, let's say, is 64. Our highest number that I can just quickly see might be 94. So essentially I want numbers that are in their 60s through to your 90s. So numbers in the 60s, 70s, 80s and 90s. And conveniently, there's 4 spaces left for exactly that. So I know that the stem part is going to be the tens of my number, and the leaf is going to be the units. So I split my numbers up like that. And with a stem and leaf diagram, you always need a key. So you'd say, for example, if I'm going to be starting in my 60s, you'd say 6, 2 means 62. So I'm just splitting my number up so that the stem holds the tens, and then the leaves are just the units, just so that it makes it easier to see all these numbers. Now, what's really helpful is doing a rough stem and leaf diagram, just because it helps when you have so much information, it's easy to miss. So I know I'm going to have my 60s, 70s, 80s and 90s, and I just go through it. So I've got 76, so I'm going to write a 6 here. 82, so I'm going to write a 2 here. 84, so I write a 4. 69, so I write a 9. 80, so I'm going to write a 0. 64, 70, 81, 75, 91, 87, 67, 80, 70, 94, 76, 81, 69, 71 and 77. So I've got my rough one here, but a stem and leaf diagram always needs to be ordered. So you've got your key here, don't forget, and that's a key part of the question. I'm going to write 6, let's rub those out, 6, 7, 8, 9, and now I can write it ordered. Doing a rough one makes your life infinitely easier. The amount of people that lose marks just because they didn't do the working and they missed out 1 or 2 by accident is quite high. So don't be one of those people. So then to order it, I look over here and I look for the lowest number, 4. So I'll write that and cross it out. Then 7, then 9 and 9. Then I've got 0, 0, 1, 5, 6, 6 and 7. Then I've got 8 and 0, 0, 1, 1, 2 and 4. And then finally I've got 91 and 94. Now to double check, it says that I've got 20 students. So let's just count my numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, what? So I've missed out a number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so what have I missed out? Oh, I think I've missed out the 7. There we go. See, I could have been that person that lost the mark. So it's always good to double check. Then told that one of these students is going to be chosen at random, and the pass mark in the French test is 71. So to pass, you need to get 71 or above. Omar writes, the probability that the student failed the French test is 1/4, but that he is wrong. Explain why. Well, let's figure out what the actual probability is. So 71 is over here. So anyone that got 71 or above is passing. So how many people was that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I know that 14 people passed, and I know there are 20 people in total. To work out probability, you always write the number or amount over your total. So 14 out of 20 is the probability someone passed, and I could simplify that. 14 over 20 is 7 over 10 if I divide by 2, and 7 over 10 is 70%, whereas 1/4, oh wait, I hadn't, see, read the question carefully. So the probability that the student failed is 1/4. 1/4 is 25%. Again, to turn a fraction to a percentage, you could just type it into your calculator. 1 divided by 4 times by 100. He said that the probability that the student failed is 25%. He is wrong, because the probability they failed is 30%, because if 70% pass, then 30% must fail, because percentages have to add up to 100 in real life situations anyway. Okay, so in this question, I'm told that Jenny is asked to find the value of 12 take away 2 times 4. Here is her working. So whenever you are doing anything in maths, you always have to use the law of BIDMAS. which is the order of operations, or it tells us which order we do multiplication, division, subtraction, addition, brackets and indices. So whenever I look at something like this, I should instantly be thinking of BIDMAS. Now, what I would probably do is just think to myself, what would I actually do myself before I even look at Jenny's working? Because sometimes it helps to actually just think, what is the actual answer? And that makes it easier to see what the person's done wrong. So I know, using BIDMAS, that first I do anything that is in brackets. For the B is brackets. Then I would do anything that has index laws, so things like if I said 6 squared, or if I had to find out the square root of 16, that's what an index is. Division and multiplication are next, and then finally we do addition and subtraction. So I know, using BIDMAS, that I'm going to have to do the multiplication first. So that would become 12 take away 8, which is 4. So I know that the answer should be 4. And I know that the first thing that I should have done is multiply. So I can surmise from that, I can deduce that what Jenny has done wrong is, instead of doing 2 times 4 first, she has subtracted 2 from 12. She did 12 take 2, and then multiplied, which does not follow the laws of BIDMAS. And everything that we do in maths, every calculation, even algebra, must follow the laws of BIDMAS. So whenever you see a calculation, you know, if anything is in brackets, that's the first thing you do. If there's indices, that's the thing you do next. Division, multiplication always come before subtraction and addition. Then I'm told that Rehan is asked to find the range of the numbers. So once again, think to yourself, what is the range? The range is the difference between the largest number, or largest value, and the smallest value. So to work out the difference, you subtract. So you do the largest value, take the smallest value. So if I did that, the largest value here is 8. The smallest value is 1. 8 take 1 is 7. So what did Raheem do? Well, it looks like he just did the end number and the first number, assuming that the numbers were in orders of size. So explain why it is wrong. Raheem should have subtracted the largest value from the smallest value, but instead he found the difference of the first and last number. So you actually don't really need to go into that much detail. It would have been fine for you to just say the range is the difference between the greatest and the smallest, so that he's wrong. And similarly for this one, you could have just said she should have multiplied first. But it's always good to give a little bit more detail. Okay, next I have a fractions question. So I'm told Alan, Bispa and Chan share a sum of money. Alan gets 1/8 of the money. So I know Alan gets 1/8. Bispa gets 1/2 of the money. And Chan gets the rest of the money. I know that Alan gets £2.50. So I know that 1/8 is equal to £2.50. And I need to work out what half of that money is. So there's a few, well, there's loads of ways that we could do this question, but one of the best ways is to try and just to visualize what's going on. So I know that the money is split into between Alan, Bispa and Chan. I know that Alan gets 1 out of the 8 parts. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And let's just rub this bit. No. Okay, well, we'll just create it again. So 1, 2, 3, 4, 5, 6, 7, 8. So I know this is the total of the money. And I know that Alan gets 1 out of those 8 parts. And I'm told that 1 out of those 8 parts is equal to £2.50. So that must mean that each part is equal to £2.50. And I could fill this in, but I don't need to. I just know that 1 part, or 1/8, is £2.50. I know that Bispa gets half of the money. So again, there's a few ways we can do this. A half is equivalent to what out of 8? Because I know that in total it's been split into 8 parts. Well, if I multiply 2 by 4, that gives me 8, so I'd multiply 1 by 4, which is 4/8. So Bispa gets 4/8 of the money. And how could you work out what 4/8 is? Well, we know 1/8 is £2.50, so we'd have 1, 2, 3, 4/8. So we do 4 times by £2.50, which is £10. For the next part, I'm told to find the ratio of the amount of money Alan gets to the amount of money Chan gets. So once again, let's just write it out. I know that Alan gets an 1/8, Bispa gets a half, and therefore that's 4/8. So I need to figure out what Chan gets. So I could just draw it out again to visualize it. So 1/8 means a whole has been split into 8 parts. So 1, 2, 3, 4, 5, 6, 7, 8. I know Alan takes up 1/8. Bispa, I've worked out, takes up 4/8. So 1, 2, 3, 4. So that must mean that Chan gets 3/8 of the money. So I need to find the amount of money Alan gets and write it as a ratio to the amount of money that Chan gets. And Alan gets 1 part, while Chan gets 3 parts. So I just write that ratio as 1 to 3. So it sounds like it's quite a confusing question, but if you visualize it, it honestly makes things so much easier, because you can literally just see, okay, well, it's been split into 8 parts. Alan gets 1 of those, Chan gets 3 of those. Next, I'm told that ABC is an isosceles right-angled triangle, and I'm given the area of the triangle, and I'm told to work out the value of x. So again, there's quite a few ways that we can do this. The fact that it's an isosceles means that these 2 sides are the same. It's a right-angled triangle, and I know what its area is. If you like visualizing with a square, no, let's not do that way. Well, it honestly depends on what your form of knowledge is, but let's just go with the area of a triangle. So you always try and think to yourself, what knowledge do I know? Well, I know that the area of a triangle is base times by the perpendicular height divided by 2. So often, as long as there's a right angle, they're the 2 heights that you're going to use. So the base is 3x, the height is 3x, and then I'm going to have to divide that by 2. So I can just think to myself, okay, I'm going to use the formula for the area of a triangle. This is the formula. I've been told that the area of the triangle is 162, so therefore I know 162 equals 3x times 3x divided by 2. So now it's up to me to simplify that. So 3x times by 3x, that's the same as saying 3 times x times 3 times x. 3 times 3 is 9, and x times x is x squared. And then that's being divided by 2. So I want to rearrange this because I want to find the value of x. So to rearrange an equation, I essentially move everything from one side of the equation to the other, by doing the inverse function. So you can use a function machine to help you decide what you need to do first. So when we use a function machine, we start with x and we think, what's the first thing that's happening to x? Well, it's being squared. Then it's being multiplied by 9. And then finally, it's being divided by 2. And I know that the end result of that is 162. So to work out what x is, I'm going to go backwards using the function machine and do the inverse operation. The inverse of dividing by 2 is timesing by 2. The inverse of timesing by 9 is dividing by 9. And the inverse of squaring is square rooting. And that's going to tell me what x is. You can use the function machine to determine what you do first, or you can just use the inverse laws of BIDMAS. So the first thing I'm going to do to solve x is times by 2, just like it tells me here. So 162 times by 2 is 324. So 324 is 9x squared. The next thing I know I need to do is divide by 9. So I divide both sides by 9, and that cancels out here. And 324 divided by 9 is 36. So I know that 36 is x squared. And if you don't know your square numbers that well, you just write in the square root of 36 on the calculator, and that will tell you what x is. But otherwise, you might know that the square root of 36 is 6. So you've worked out that the value of x must be 6. So it is quite a tricky question. There are quite a lot of things that you need to know, but primarily it's applying the area of a triangle, simplifying your algebraic expression, and then solving it. Okay, next we've got a standard form question. So this is a calculator question, so we can just type it into our calculator. So you use the fraction button, you type it in 2.645 times, and if you don't know how to do the power of, you press that button there where it's like a box and then a thing on top of it, and we write 10, use the arrow, go to the power of 9 over 1.15 times 10 to the power of 3, which gives me 2, 3, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. So that's 2,300,000. Now to put something in standard form, I write it as a number between 1 and 10. So that would become 2.3. And then times by 10 to the power of 1, 2, 3, 4, 5, 6. Okay, for question 19, it's a scatter graph. I'm told that the scatter diagram shows information about 12 girls. It shows the age of each girl and the best time she takes to run 100 meters. I need to write down the type of correlation. So with scatter graphs, there's really only ever going to be 2 types of correlation, maybe 3, but I haven't ever seen no correlation in an exam. So there's either going to be negative correlation or positive correlation. So negative correlation is where if you drew a line of best fit, which means a line going through as many of the points as possible, is it going down? Is the relationship down? So essentially, as the girls get older, so a 15-year-old runs, I don't know, roughly like 11.5 seconds. A 9-year-old or a 10-year-old runs roughly 16.5 seconds. So the older the girl is, the less time it takes to run. So there's a negative correlation. As the girl gets older, the time decreases. So the type of correlation, I would just say, is positive correlation. Then I'm told Christina is 11-year-old. Her best time to run 100 meters is 12 seconds. The point representing this information would be an outlier on the scatter diagram. Explain why. So let's plot that information. Her best time to run 100 meters is 12 seconds and she's 11 years old. So age 11, it would take her 12 seconds. Why is it an outlier? Because it does not fit the general trend of data. And what that means is the point is far away from the other points. So outliers are things that are far away from generally where the rest of the data is. So if we drew that line of best fit again, every point is roughly close to it. This outlier is far away from it. An outlier is something that is far away from the rest of the data. It doesn't fit. It's like an anomaly. You're like, oh, that's strange. That's unusual. Okay, for the next part, it says Debbie is 15 years old, and I'm told that Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 meters. So a 15-year-old is over here. We don't even have a data for a 14-year-old. So what I would say is the point is outside of the range of the scatter diagram. So what that means is we only have data for between 9.5 and 14. So we only have data for let's just round it up, 9.5 to 14-year-olds. So because it's outside of the range of the data, the scatter graph, we can't reliably predict it. When we have a scatter graph, we can predict, for instance, what an 11.5-year-old would be, because we can go up to the line of best fit. But it's anything that is beyond our highest or our lowest value, we can't reliably predict. Okay, next question is an expand and simplify. So when I'm expanding brackets, expand means multiply out, and simplify is what we're going to do when we've expanded both brackets. So it's a single bracket, so I can put a dot above here. I'm doing 5 multiplied by p, which is 5p, and then I do 5 times by 3, which is 15. So doing the arrows just helps to remember what you need to do. So then we've got -2, and this is the bit that people often get wrong because they ignore the negative. Remember, the positive or the negative sign always belongs to the term after it. So it always belongs to the term after. Therefore, it's -2 I'm multiplying. So do -2 times by 1, which is -2. And I do -2 times by -2p. And a negative times by a negative is a positive. So that would give me positive 4p. So I'd write positive 4p. So then once I've expanded this, I can simplify. So when I simplify, I can bring together like terms. So anything that is the same letter and the same power, I can bring together. So I've got 5p plus 4p is going to give me 9p. And then I've got 15 take away 2, which is 13. So that's how I'd do that. Okay, so in this question, I'm told that there is a trapezium drawn on a centimetre grid. So the fact that it's a centimetre grid means that each of these lengths is going to be 1 centimetre. Now, it's really important we know the formula for the area of a trapezium, and there's lots of different ways that you can write it, but the easiest way is probably to say the area of a trapezium is A plus B times by half of the height. So what do? You add the 2 parallel sides together. So A and B are the parallel sides. So the sides that are going to never meet. So that would be these 2 over here. If we continue those lines, it's like train tracks. They're never going to meet because they're always going ahead. So I know that one of them is going to be A and one of them is going to be B. The height is the vertical height, the perpendicular height. And then I just have to divide it by 2. So let's figure out what A is. I know that A is 2 squares, and then B is 1, 2, 3, 4, 5, 6, 7. So I've got my value of A and B. So I know the area of the trapezium is going to be a plus b, 2 plus 7, times by half of the height. So what's the height? Well, that's 1, 2, 3, 4. So 4 divided by 2. So let's simplify that. 2 plus 7 is 9. 4 divided by 2 is 2. So therefore the area of the trapezium is 18 centimetres squared. And now I need to draw a triangle equal in area to this trapezium. So how do I draw a triangle? How do I work out the area of a triangle? I know that it's base times height divided by 2. So I need to think base times height divided by 2 is going to give me 18. So therefore I need a triangle who's going to have a base times height that is going to give me 36. So how could I create a triangle of a height of 36? And I would recommend you just do a right angle triangle like this, because it will just make your life easier than doing anything else. So 36, let's just think of 2 factors of 36. You could do a 6 by 6 triangle. You could do a 9 by 4 triangle. Any 2 numbers that multiply to make 36. So let's just draw that. We've got 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6 here. Join them together and you've got a triangle equal in area to the trapezium. Because how would you work out the area of the triangle? You do base times height divided by 2. 6 times 6 is 36, divided by 2 is 18. So they both have that area. Okay, next I've got a probability tree. So I'm told that when a biased 6-sided dice, and biased means that it's not fair, it's not like a normal, something's happened to it, like a weight has been put on it to make it land on one side more times than the other side. So when a biased 6-sided dice is thrown once, the probability that it will land on 4 is 0.65. The biased dice is thrown twice. Amir draws this probability tree diagram, and we're told that the tree diagram is not correct. So I'm told to write down 2 things that are wrong with the probability tree diagram. So the first thing about a probability tree diagram, and just probability in general, when you've got mutually exclusive events, which means two things that cannot happen at the same time. So for instance, the dice can't land on a 4 and also land on a 5. It can only land on one side at once. So the probability that it lands on a 4 or not lands on a 4 must add to 1. So probability must always add to 1 when we're dealing with mutually exclusive events. And 0.65 plus 0.25, if I add that, does that add to 1? So 0.65 plus 0.25 gives me 0.9. So 1, the first branch is incorrect. Probability should add to 1. So therefore, if I know that this is definitely correct, this is going to need to be 0.35. The not land on 4 should be 0.35. And then the second thing that is wrong is each time it's thrown, probability renews. So the fact that it should land on 4 should always be 0.65. So this bit here is wrong. So the way you could word it is on the second throw, 0.35 should remain as 0.65 because the probability is the same. So there's, yeah, he's just made a few silly mistakes, so that's wrong. And these two should be swapped around. Okay, next I've got a right-angled triangle. So whenever you're dealing with a right-angled triangle, you should just think to yourself, they're either going to want me to use Pythagoras or trigonometry. Now, if there's an angle involved, it's likely to be trigonometry. So I'm told here is a right angled triangle and I need to work out the size of angle ABC. So ABC would be this angle here. And I've been given two sides and an angle, so I know I'm going to use trigonometry. Now, I would highly recommend that when you're doing trigonometry, you literally just write out SOHCAHTOA, little mnemonic to help you remember what you need to do. So SOHCAHTOA is just there. You label your triangle. So the first thing we do is decide what is going to be the opposite side, the hypotenuse and adjacent, and that's what SOHCAHTOA represent. So let's have a look. So the adjacent is going to be here because adjacent means next to. So it's literally the side that is next to your given angle. The hypotenuse is always the side opposite the right angle. It's always the diagonal with the longest side. And then the opposite side is the one that is opposite your given angle over here. So we label our triangle. And then what I do is I'm like, okay, I've labeled my triangle and the two sides I've been given are the adjacent and the hypotenuse, because that's the ones that you know the lengths of. You know that's 11 and that's 7. So out of SOHCAHTOA, which one uses A for the adjacent and H? Well, it's this one here. So I'm going to write out the formula. Cos theta is the adjacent over the hypotenuse. And then I'm just going to substitute things in. So cos theta, and theta just means the angle. So cos theta is the adjacent over hypotenuse. The adjacent has a value of 7 and the hypotenuse has a value of 11. So with trigonometry, when you're trying to figure out an angle, you're essentially trying to divide by cos, but we can't properly do that on our calculator. So what we do is we do the inverse of cos. So you press the shift button, you press cos, and you come up with something that looks like this, cos minus 1. So you're going to have on your calculator cos minus 1 because you've typed shift cos, and then you just type in the fraction 7 over 11, and it's going to tell you what your angle is. So that tells me that the angle is 50.4788, blah, 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 blah. It's told me to round it correct to 1 decimal place. This is the first decimal point. I'm going to circle it, look next door. It's more than 5, so I'm going to round it up. So I add 1 to this, so that would become 50.5. Okay, I'm then told that the length of AB is reduced by 1 centimetre. So let's have a look at this. The length of AB is reduced by 1 centimetre, so that's going to become 6 centimetres. The length of the side BC is still 7 centimetres. Oh, sorry, I've done that wrong. AB is this one here, so that would become 10 centimetres. The length of BC is still 7 centimetres. Angle ACB is still 90 degrees. Will the value of cos ABC increase or decrease? And this is quite a difficult question to think about unless we actually try and do it ourselves. So let's just try working it out. We know that we do cos theta is going to be the adjacent, which is still 7, over the new value, which is 10. So let's just type that in. Theta is going to be cos minus 1, 7 over 10. So what's the value of the angle going to be? Cos shift cos 7 over 10 gives me 45.572996. So it says, will the value of cos ABC increase or decrease? And we'd say it would increase as the angle sorry, I didn't read this question properly. will the value of cos ABC, so what that means is this part here. This is cos ABC. It's just another way of saying the angle. So the initial thing was cos ABC was originally 7/11. They're not asking me about the angle, they're asking me about cos angle. So it was originally 7/11, it's now 7/10. So will the value of cos ABC increase or decrease? Well, what's 7/11 as a decimal? 7 divided by 11 is 0.636. 7/10 is 0.7. So the value of cos ABC will increase as 7/10 is larger than 7/11. We didn't actually need to do this bit. Just make sure you read the question very carefully. Okay, next we've got forming and solving an equation. So I'm told there are some counters in a bag. The counters are red or white or blue or yellow. Bob is going to take at random a counter from the bag. The table shows each of the probabilities that the counter will be blue or will be yellow. I'm told that in total there are 18 blue counters. So I know that 0.45 is equal to 18. The probability that the counter Bob takes will be red is twice the probability that the counter will be white. Work out the number of red counters in the bag. So what I want to do here is think to myself, I don't actually know what the probability of it being white will be. If I don't know something, I can use algebra. So I can just say the probability is going to be X. I'm told that the probability that it's red is twice the probability that it's white. So that would be 2 times by X, which is 2X. I know the probability of blue is 0.45. I know the probability of yellow is 0.25. And probability of mutually exclusive events should add up to 1. So therefore, if I did 0.45 plus 0.25, that gives me 0.7. So I know that this adds up to 0.7. So these two must add up to 0.3. So I know that white, which is X, plus red, probability, must add up to 0.3. What's X plus 2X? That gives me 3X. So 3X is 0.3. So X must be 0.1. So if white is X, then that means white is going to be 0.1 and red is going to have a probability of 2 times 0.1, which is 0.2. Double check that they all add up to 1. 0.2 plus 0.1 plus 0.45 plus 0.25 adds up to 1. So therefore, you know you have done it correct. So we've worked out the individual probabilities and I need to now work out the number of red counters in the bag. So 0.45 probability is equal to 18 counters. So I could figure out how much one counter is. So 18 counters is 0.45. So one counter, if I divide 0.45 divided by 18 is 1 over 40, which is 0.025. So how many lots of 0.25 fit into 0.2? I could do 0.2 divided by 0.025, which is 8. So there's 8 red counters. This is quite a tricky question. So I'm told that a marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. I'm told there must be an even number of marbles in the box. Explain why. Well, 0.5 is equal to a half. And a half of something, you can only halve whole numbers. You can't have half a marble. So for instance, if the probability is 0.5, that means half of the marbles are silver. You can't have half a marble. So, and any number doubled is an even number. Well, any integer, should I say. So any integer, which is a whole number, and it needs to be a whole number because marbles are whole. So 0.5 multiplied by an odd number is never going to be a whole number. Could also be another reason. But these reasoning questions are difficult. It's just about thinking, how can I apply this to real life? Next, I've got solving an equation with x on both sides. So this one is a little bit trickier. When you've got x on both sides, you want to keep moving things around until you only have x on one side. So first thing we could do is, I know this is a fraction, to just make my life easier. This means divide by 2. So the whole side is being divided by 2. So I can just times both sides by 2 and see where that takes me. So that would become 5 minus x equals 2 lots of 2x minus 7. And it's a lot easier if you just put things in brackets to indicate that you're multiplying by 2. Then you can expand the bracket. 2 times 2x is 4x. 2 times minus 7 is minus 14. Now we get to a part where we've got x on both sides, so we can move the smallest x. So it's a minus x over here. If I add x to both sides, that would become 5 equals 5x minus 14. I then can do the inverse and add 14 to both sides. So 5 plus 14 is 19. So 19 equals 5x. And therefore, if I divide both sides by 5, x is 19 over 5, which it says solve. So leaving it as 19 over 5 would be fine. But it's better if you can write it as a decimal as well. Okay, next we've got a pentagon. I'm told that angle BCD, so this angle here, is 2 times angle ABC. ABC is this angle here. Work out the size of angle BCD. Okay, so first of all, when I've got angles in a polygon, you use the formula n minus 2 times by 180 to figure out what the angles in the polygon must add up to. N represents the number of sides. In this case, it's a pentagon. It's a 5-sided shape. So you do 5 take away 2 times 180. So that's 3 times 180, which is 540 degrees. So I know that the angles in this pentagon, or any pentagon, must sum to 540 degrees. So I know that this angle here is a 90-degree angle because anything that looks like this is a right angle and it has a value of 90 degrees. So I could start by doing 540, take away 90, take away 115, take 125 to figure out how much is left. So 540, take 90, take 115, take 125 gives me 210 degrees. So I know that this angle and this angle must add up to 210 degrees. Now I'm told that angle BCD is 2 lots of the first angle. So angle BCD is 2 times angle ABC. Let's just make it a little bit easier. Let's call this X and Y. So angle Y is 2 times angle X. And I know that they must both add up to 210 degrees. So what I could do is think to myself, y plus 2x must equal to 210 degrees. And actually, I probably made this more confusing. Let's start again. So let's not label it x and y. Angle BCD equals something. Angle ABC equals something. I know that angle BCD is 2 times whatever angle ABC is. So let's call ABC angle X. So if angle ABC is X, angle BCD is going to be 2 times X, which is 2X. So that makes life a lot simpler. So I know that 2X plus X must equal 210, and 2X plus X is 3X. So if 210 equals 3X, I can divide by 3, and 210 divided by 3 is 70. So X must be 70 degrees, and I need to work out angle BCD, which has a value of 2X. So angle BCD is going to be 140 degrees. Okay. Next, I'm told that I've got 2 similar triangles. If the triangles are similar, it means they are multiplied by the same scale factor. So, for instance, this would be a similar triangle. Let's say that's 8. I'm like, okay, I know that this triangle is 4 times larger. So if this side was 6, this side would be 24. You'd multiply each side by a scale factor. So this first thing that we want to do is look for 2 sides that are corresponding, so in the same place in each triangle. So AB and DF are the same. So I know I need to figure out what I'm multiplying this triangle by to get to that triangle. And to work that out, I've got 12.6 here and 8.4 here. So I could do 12.6 divided by 8.4. This is going to tell me the scale factor. So 12.6 divided by 8.4 is 3/2. So that's 1.5. So I know that this triangle is 1.5 times larger. So I need to work out the length of DF. Where's DF? Over here. So I know the corresponding side over here is 6.4. I've worked out that the scale factor is 1.5. So I'm going from the smaller triangle to the bigger triangle. So I'm going to times by 1.5. And 6.4 times by 1.5 gives me 9.6. So it's going to be 9.6 centimeters. Then for the length of CB, it's this one here. I know it's 15 centimeters on the larger triangle, but to get from the larger triangle to the smaller triangle, I'm going to have to divide by the scale factor. So 15 divided by 1.5 gives me 10. So CB is going to be 10 centimeters. And now for the final question, I'm asked to make G the subject of the formula. So when something is being made the subject of a formula, it means you're rearranging it, moving things from one side to the other to get it in the form G equals. So again, you could use function machine to help you figure out what you need to do first. And I would actually probably recommend that because this is a slightly complicated one. So you look at G, what's the first thing that's happening to it? You're adding 6. Then what's happening is being divided by 2. And finally, the whole thing is being square rooted. And what comes out is T. So I'm going to work backwards. What's the inverse of square rooting? It's squaring. The inverse of dividing by 2 is timesing by 2. The inverse of adding 6 is subtracting 6. So I've got t equals the square root of g plus 6 divided by 2. I know the first thing I'm going to need to do is square both sides. So t squared is going to become g plus 6 divided by 2. I'm then going to need to times both sides by 2. So that would become 2t squared equals g plus 6. And then the final thing I need to do is subtract 6. So 2t squared take away 6 equals g. And it doesn't matter which way you write it, g equals 2t squared take away 6, both the same. Okay, so thanks for watching. Some of those questions are quite tricky, so let me know if you want a more detailed topic overview on any of those. But yes, apart from that, good luck with revision.